An overview of computers and programming languages. So basically it's a chapter 1 from the book C++ Programming 8 edition DS Malik. An overview of computers and programming languages. So in this video now we will discuss about introduction to computers. What is computer? A computer is an electronic machine that processes information. It takes input from the users and processes it and gives the output. Computers are used for many purposes like studying, working, gaming, and communication. As all of you know, computer is an electronic device which works on a pattern of taking input from users and processes the data, analyze the information, and give the output, which is the processed data for the users. Now, parts of a computer. As computer is a machine, it has many parts and the main are hardwares, which are the physical parts of the computers, which are visible towards the users, and the physical parts are keyboard, mouse, monitor, and CPU. So CPU is the central processing unit of the computer. And software. The programs and applications that run on our computers are known as software. So their examples are web browsers, games, and word processors. As there are many softwares, as the internal processing unit of the computer works on all of that software is that, but basically that works are web browsers and games and word processors. And so what's the history of computer? So as there is history behind everything. So the first device known to carry out calculations was the abacus. The abacus invented in Asia but was used in ancient Babylon, China, and throughout Europe until the late Middle Ages. The abacus used a system of sliding beads in the racks, and all their discoveries lead towards the invention of a computer, which is now a most commonly used devices in today's modern world. Now, computers have come a long way from simple counting tools to powerful machines that can perform complex tasks. Here are short histories of how computers developed over time. And so, as you know, inventions are made day by day. So, modern day computers are powerful, reliable, and easy to use. They can accept spoken word instructions and imitate human reasonings through which is the most used thing nowadays, AI, artificial intelligence. And as you know, AI has very much vast impact in the future, as we will see. So as now computers and AI is using in almost every field of life, like medicines. Computers are used in study, education, and whatever it is, computer and AI is using in it. So the change of how the computers were invented. Number 1, early calculation devices which were before 1800s, which was abacus. It was around about 3000 BC, and the first known tool for counting and basic calculations. It was the time when the inventions were start making regarding computers. And the second one was Pascal's calculator, which was in 1642. There was a mechanical calculator invented by Blaise Pascal to help with additions and subtractions, as we have studied it regarding this. And the number 2 is first mechanical computers, and after the Blaise Pascal's invention, then second number was mechanical computers, which is around 1800s, early 1900s. Like after 1800 but before 1900s. So it was analytical engine 1837, which was designed by Charles Babbage. This was the first concepts of programmable machine. So here is the more modern techniques of inventing computers. So the punch card machines in 1890s, late 1800s, and used in early data processing systems, and which was developed by Herman Hollerith. So the third one is first electronic computer. Now here the computer has finally been developed, which is in 1930s to 1950s. It was start of 1900s era, as ENIAC in the first electronic computer. The first general purpose of electronic computer used for military calculations, like it was at that time it was invented for military calculations, and UNIVAC in 1951. The first commercial computer used for business and government applications, like two types of computer was invented that time, one for military use, military purposes, and other was like business and government application, which were used by civil peoples. So the fourth one is the rise of modern computers. Now computers are getting modern day by day as centuries are passing. So in 1960s to 1990s, the transistors were finally made, and there was 1950s to 1960s transistor was made. The made computer is smaller, faster, and cheaper than earlier vacuum tube computers. So the next is microprocessor, which was invented in 1970s. So finally the microprocessor has been invented. So the next is allowed this creation of personal computer. PCs are also invented, leading to brand like Apple and IBM, as Apple and IBM been starting getting invented in 1970s. And the next, finally, the internet in 1990s. Computers become connected worldwide, changing how we communicate and share information. And finally the computer era is getting modern. Like next, move towards the next. And this is the fifth and the last chain of the computer invention, which is computer today's and future. Like we have reached the modern computer, which is present in your homes right now and in your hands right now, which is smartphones and computer PCs of today. So computer today and future 2000s present, smartphone and AI 2000s, and now computer became portable, intelligent, and integrated into everyday life. So and in future, which is expected to be as a quantum computing. Scientists are working on ultra powerful computers that could solve complex problems faster than traditional ones. As you know about AI, which is a shadow of like what is going to be happen in the future. So now we will move towards the elements of the computer. And so here the first one is hardware. You all know about what is hardware. And the physical parts of a computer, such as input devices like keyboard, mouse, scanner, and it helps enter data into the mouse. As you all know, computer works on a pattern like input, process, and output. So the devices that take inputs from the user are known as input devices. So that includes keyboard, mouses, scanners that help data into the computer. The next one is processing unit, which is also known as CPU, that acts as the brain of the computer and processes instructions. And next, storage devices are hardware, SSD, RAM, store data temporarily and permanently. And the last one is output devices, which are monitor, printer, speakers, display or present information to users. The next is central processing unit and main memory, which is also known as CPU. And here is a flow chart of diagram you can use. You can see that central processing unit, and which gets main memory and secondary. So you can understand very clearly, and that as the flow chart is explained here. Now we'll move towards secondary storage, is where a computer stores data permanently for future uses, unlike RAM, which is random access memory. And primary storage, that storage data is primarily stored in RAM, and which is a temporary. Secondary storage keeps files even when the computer is turned off. Like when the data is stored in the computer, it is stored in RAM. So next is what is a software in the computer. As I have already told you before, what is software. So software is a set of instructions that tells a computer what to do. It is not a physical part of the computer like hardware, but it helps the computer work and perform tasks. As software are instructing the computer that next what you have to do. Like software, without software computer cannot do anything. Computer is doing what the software is telling the computer to do, as the computer is a set of instruction that tells the computer what to do, and it is not a physical part of the computer like hardware, but it helps the computer work and perform tasks. Now, what are the types of computer? There are many types of what are types of software? There are many types of software. System software and that runs a computer and manage hardware. examples are Windows, Mac OS and Linux. They are the examples of system software. The next is application software, programs used for specific tasks. Like examples are MS Word, games and web browsers. There are two types of software, system softwares and application software, and they're explained here. So the next topic is the languages of a computer. There are two types of electrical signals, and the analog signals and digital signals. Basically, there are signals behind the languages of a computer. So analog signals are continuously varying, continuous waveforms used to represent such things as sound. Audio tapes, for example, that store data in analog signals. And the next signals are digital signals that represents information with a sequence of zeros and ones, like binary. A 0 represents a low voltage and a 1 represents a high voltage. Digital signals are more reliable carriers of information than analog signals and can be copied from one device to another with exact precision. As if you do a comparison between analog and digital signals, so the digital signals are more reliable than analog signals. So here is the data chart. You can see of the signals like unit representing units, symbols and bytes and bits. Like one byte is equals to 8 bits, and kilobytes, and they all the line wise of byte, kilobyte, megabyte, gigabyte, terabyte, beta, exa and zettabyte, and all their chart is given below as KB, MB, GB, TB, PB, EB, and like whatever you can see in the chart is here. So the variations of programming languages. Programming languages have developed over time to become easier to use, more efficient and more powerful, as each thing is getting modern and precise day by day, as a word is changing towards precise and technical. So what is a binary language? Binary language is a basic language that computer understands. It consists of only two numbers, zeros and ones. Every instructions, data or program in a computer is converted into binary before processing, as there is the language each thing that can understand. So the language a computer understands is binary language. And so why do computer use binary language? Computer works with electrical signals I discussed before, analogs and digital signals. So zeros are electrically flow and one are also on and off. There are some signals and examples of binary codes as letter A in binary and the number 5. How is binary used in storage data in hard drives and necessarily is silence in binary. And so here is the processing C++ program. As the binary computer language is basically a C++ program, it works on which. So when a C++ program runs, it goes through several steps, which are basically the writing codes. Either are steps in each and everything to make it easy. So the following are the steps to write a program in C++ program. So the first is writing the code. You write the program and save it as a CP file. So the next is pre-processing. The preprocessor handles special instructions like #include. And this is the pre-processing, like you have to add the header files. The third one is compiling. The compiler converts the code into machine language but does not run it yet. Like when you compile, before running the program, you have to compile it before running. So the third is compiling, and the next step is linking. The linker combines the program with necessary libraries to create an executable file. So after compiling, you have to do the linking task, and the fifth is execution. So the operating system runs the program and you can see the output. So the major 5 steps of C++ programming are writing the code, pre-processing, compiling, linking and execution. There are simple flowchart below that writing the code, preprocessor, compile and link, execute, and your program will run. This process can ensure that the computer can understand and run your C++ program. And here is the flow chart of explaining you the C++ programming in more efficient and easy way, as the human brain can pick the graphical data more easily. So the C++ program, the first step is editor, and the next step is preprocessor, we have discussed before. So the next step is compiler, as you know, and the syntax error can be there if in compiler you have to go to the step 1, which is the editor. So the next step is linker, that link your program data towards the library, associate it with the library, which is a step 4. And the next is step 5, which is the loader. Next step is loader, and then the last step is execution. You will execute your program and see if your program is running or not. And there are some steps listed here, and the basic steps are editor, preprocessor, compiler, linker, loader, execution, and after that your program will run. Whether it is running or not, you will see. And now you have to do the example. In this example, we design an algorithm to find the perimeters and area of a rectangle. So to find the perimeter and area of a rectangle, you need to know the rectangle's length and width. The perimeter and area of the rectangles are then given by the following formula. As you know, to find the area of a rectangle, you need to know the length and the width of the rectangle. So the perimeter is equals to 2 minus 2 length plus width, and area is equal to, and the algorithm to find the perimeter and area of a rectangle is as follows: get the length of the rectangle, get the width of the rectangle, find the perimeter using the following equations. Perimeter is put the formula here, and find the area using the following equation. And this is how you can find the needed object in the C++ programming or computer language using the algorithms to find the perimeter and area of a rectangle.